We begin a question answer session on digital electronics, and this is the first lecture of this new series. Let us begin with the first question, which is as follows. The binary equivalent of 22.5625 is, and the options are A, B, C, and D, where sign bit representation is used. The answer: given decimal number is 22.5625. Let us mention that in sign bit representation in binary number system, a positive number corresponds to sign bit 0, that is, and 1 indicates a negative number. Now 22.5625 can be dissolved into two parts. The integral part is 22 and the fractional part is 0.5625. Now consider the integral part 22. We have to divide 22 by 2, and if we do that we get quotient 11 and remainder 0. We again divide by 2 to get quotient 5, remainder 1. Division by 2 again gives 2 as quotient, remainder 1. A further division by 2 gives quotient 1, remainder 0. Divide by 2 for the last time to get quotient 0 and remainder 1. We have obtained a string of numbers. How shall we read it? It is in this manner, bottom to top. So we have got 22 base 10 equal to 10110 to the base 2. What about the fractional part? Let us write it. It is 0.5625. Multiply by 2 to get 1.125. Integral part 1 is to be carried over. The fractional part 0.125 is multiplied by 2 and we get 0.250, and we carry over the integer part 0. The fraction part 0.25 is to be multiplied by 2. We get 0.50 and carry over the integer part 0. 0.5 is the fractional part. Multiply by 2 to get 1.0 and we carry over the integer 1. How to read this string of bits? This way, from top to bottom. So we have combined the integral part and the fractional part now to get. We shall write the sign bit here and after that the number bit. We thus end up with. Let us repeat. This is the sign bit and this is the number bit. This is the sign binary equivalent, and option B is the correct option. Next question. The 2's complement representation of -17 is option A, option B, option C, option D. The answer. Let us find binary equivalent of +17 base is 10. Divide 17 by 2. Quotient is 8 and remainder is 1. Division by 2 gives quotient 4 and remainder 0. Further division gives quotient 2, remainder 0. Another division by 2 yields quotient 1, remainder 0. Dividing once again gives quotient 0, remainder 1. We have to read the string of bits from bottom to top and we get positive 17 has sign binary equivalent as sign bit to be 0, as we have referred to a positive number, and this is the number part. So this is the sign bit and this is the number part. Let us take 1's complement to get. Add +1. This gives what is called 2's complement, which is a negative number. This bit represents sign of the number and this part is the number part. It represents negative 17 in decimal representation. So the option B is correct.